All right, welcome everyone. I was asked to do a training for garment systems, and I was kind of thinking about what we haven't done yet. So we've done intro training to the Transline, we did some maintenance, a little bit of maintenance training, we've done an XMT, we've done optimizations, we went into some of the special components and stuff like that. I know all you guys may have not had all of those, but it's okay, we don't need it. What we're going to talk about today is troubleshooting information and best practices for garment systems. So what I'm hoping to do today is to kind of give you guys a little bit of path, a little bit of direction on how to go about handling a W-2 call. Okay, we're doing a lot of full laundries now, and poor Jacob's getting called off of the W-1 to come over there. Chris, other people are being pulled off, you know, their W-3 getting pulled off a lift, fixing E-rail or whatever, and say, hey, what's going on with the garment system or whatever. And you guys, the first response is usually go up, look, and then 1-800-William, okay, which is fine. But what we want to do is for you to be able to maybe find a little bit better path, a little bit of knowledge, get a little bit self-sustaining. And then if you do have to call me, we've already done 5, 10, 15, 20 minutes of the work that I'm going to have to get to do anyways. Okay. So what is troubleshooting? Troubleshooting is a form of problem solving, usually used to repair failed product processes or machine systems. It is a logical, systematic search for the source of the problem to find a solution to fix the problem and to let the product or process work again. Okay, you guys are all very comfortable with your W1, W3 EVs. Okay, you guys do a lot of this troubleshooting in your head, but what we have to do is you guys aren't the subject matter experts right now. Okay, we're going to get you guys there someday. Okay, but you're not right now. So we got to go back to the way we did it in the beginning. Jacob, you get called over to look at the garment system. They come over and say, garment system's broke. What's the first thing you're going to do?
Call William. Check the damn alert first.
Okay, so the first thing you're going to do is kind of elaborate on what's broke. You're going to look for an alarm or something like that. Somebody else.
Look what's in red.
Look what's in red. Look what's blinking. Okay, whatever. What else?
Ask them what fault is there.
Ask them for any faults that are present.
Ask them what troubleshooting they've done.
Bing, bing, bing. What have you done? Okay. So the steps of troubleshooting, the way I like to break it down, the first thing is symptom recognition. Okay, we have to identify something is not working like it's supposed to work. Okay, and this is usually, you know, EVU is not down, ironing line 1's not working. Okay, garment system isn't producing, whatever. Great, that really doesn't tell us a lot, right? So this is where we have to get into a symptom elaboration. And those are a lot of the examples that you guys were giving. What alarms do we have? What isn't moving? What isn't happening that you would expect? Okay. Next thing we have to do is we got to break it down by a list of probable faulty functions. Is this a mechanical? Is this a pneumatic? Is this electrical? Is it software? Is it database? Is it inter-machine communications? Okay, we got to start listing what these things are and start eliminating. With the W-2 system, I can literally have one fault and it could be one of 5 different functions, and it drives customers nuts. Drives them nuts. They're like, well, what do you think it could be? Well, it could be this, or go over in this totally different area. It could be this, or go in this totally different area, and it could be that. And they're like, why can't you just tell me where to go? Because you've got to get in and look. You got to look at these things. Then, obviously, what we're going to do is we're going to start eliminating the functions that are non-applicable. Okay? You said it was air, electrical, and software. Okay, you go over yeah, I got 6.5 bar on my gauge, that's good. And my cylinders are going up and down at a correct speed. All right, not air problem. Chunk it out, and now we go to the next one. Okay, we just start eliminating those different functional areas. Then within that area, we try and come down to the component. And the component can be an IO card. The component could be a pneumatic cylinder. It could be a sensor. It could be whatever, okay? We get down to that lowest level that we can go. And then the most important part that just about everybody in the laundry forgets, and hopefully we don't, because we're professional technicians, okay? Failure analysis. Why did this happen? Okay, were we not cleaning air filters and something overheated? Okay, were we overloading something? 130, 40, 50% of its expected capacity, and this is why it gave out. Okay, if we're not doing this failure analysis, we're doomed to repeat this fault in the near future. Okay, so where do we start? Some of the questions you can ask customer: what aren't you able to do? Were you able to do this before? A lot of times programming requests come in under troubleshooting calls, right? They want something changed. They say, hey, I can't do this. And they don't tell you that this is a wish list item, okay? This is a development item. So this is very important, especially with you guys not being as familiar with all the ins and outs of some of these things. Right now, if somebody would call me up on the Vectura or something like that, I don't know, it's broke. Okay, I'll get in there troubleshooting it. And then I find, you know, I talk to HKD and they're like, well, it's never been able to do that. Is it just one area or is it happening elsewhere? Okay, eView is very good about this. This is one rail port or every rail port. Okay, is it one drop? Is it every drop? Okay, these are the kinds of things we need to ask. The other good thing with that is it gives us hopefully a known good now that we can use in our troubleshooting process. Okay, they call you about a folding machine and it's acting all screwy. You got a perfectly good one right next to it. There's your example, and we can go off of there in our troubleshooting. Okay, has it ever worked? Okay, we know that we get these punch list items that come up and they just stay there, and then they kind of, you know, hide out in the corner for a while, and we find out that, you know, this install from 2.5, 3 years ago, we never knocked out the 1 or 2 punch list items that we made a ticket for and assigned it to a programmer, and we never followed up. Okay, and then has anything changed recently? This is one of the hardest ones, I think, to get our customers to play fair. Okay, Paul, does everyone that calls you tell you everything that they did before it's all jacked up?
Absolutely. I never get any misleading information.
Never any misleading, never any vague information. They're always 100% upfront on what they were just PMing. They didn't have the right materials. They tore something apart, springs, pa-ding, da-ding, da-ding, all over the place. Yeah, hopefully we got everything put back together and torqued. Okay, so you need to build up your rapport with your customers. All right, some of the information to gather. Okay, what kind of system is it? And this is basically, we're all going off a Transline right now. So we have different versions of the Transline. We have a first in, first out, which is a very simple system, like we have at Cooperative Kearney, Cooperative San Marcos, Reno Linen, some in Hawaii. It's like the old Colmex, very short feed in, it goes through the tunnel, it slides out onto a rail, and that's it. Okay, first in, first out. Okay. Then, or is it a sortation system? Okay, where we're actually marrying garments at a rapid loader station, we're querying databases, we're sending them through the system so we can get all the extra small together, all the smalls, all the blues, all the greens, and everything together. Okay, and then another important thing is whether it's a hanger system or adapter system. So most of all you guys have only seen the hanger system. Okay, that's where it'll be on the Conageser mechanical hangers, and it's those tannish ones that are going out throughout the system. And then they'll collapse inside the folder and then get folded. We have an adapter system, and this is a special type of hanger. It's kind of a hook and a body, and you hang a normal one-way wire hanger off of it. Okay, so these are typically going to be at uniform plants where they do not fold their items, that nearly all of their stuff go out on hangers. Okay, and there's a couple of things that come into play with that, and that's why I just want to throw that in there. What area is affected? Try and find a general area. Is it the in-feed area, the rapid loaders? Is it the sort? Is it the sortation? Is it the storage area? What area appears to be where the bulk of the problem is? Okay. You guys do this all the time, right? Guy calls up, says, oh, it's an iron line. Iron line's broke. Well, they call it an iron line, but the problem could be with the feeder, it could be with the folder. So find the general area, the locale that it's happening in. We need to find the identification of the conveyor component. Okay, this is very important, and we're going to talk about this later. How many people have seen a garment system, a full-blown one? Economy, no, UHS, some of these other places, these bigger ones. Come on. You walk in and you look at this thing, and it's just all over the place. It's a, you know, a little E-rail, okay? And trying to find something can be very confusing, okay? So try and get some kind of designation. The plus 5.2.1 is referring to a specific conveyor number. If we remember from some of our previous trainings, each of these conveyors are broken up into an individual subsystem, okay? So one conveyor will be 5.2.1, then it transfers to another conveyor, which would be 6.1, transfers to another conveyor that may be 15.1, and so on and so on, okay? So to get that conveyor number helps localize it. And then the other example I gave is rapid loader number 2. So this is one of the in-feed stations where they put the garments onto the hangers. Rapid loader 2 is okay, but just like we went through with economy, programmers may have an idea of what rapid loader number 2 is. Technicians that install it or know what number 2 is. Then you get a customer and they put a sticker on it that says station 4. Okay, so now we're troubleshooting wrong IPs, wrong IOs, and all that. So the conveyor number is the best way to go. Component ID or function, the specific sensor, B26 is this a specific sensor, and it happens to be a full sensor in the system that we're going to be using for an example later on today. IP addresses. This is also helpful, okay? For our Transline systems, we're all on the 10.8.15, which is the overall IP address for the RAU, 10.8.15.254, and then our major systems components will be a 10.8.15, like the server or maybe an operator PC or something like that. Then when we get down to individual components in there, the PLC for the Transline, the display for rapid loader number 1. Those will all fall under the 10.8.2 IP address. So if you're going to be doing an IP searching, it's going to be a 10.8.15 or a 10.8.2 that I would recommend, with a couple exceptions that are really old systems.